Welcome to my CS 1160 presentation on functions. Okay, functions are a tool we can use in C++ programming or pretty much any language programming that allows us to program in a modular way. A modular way is a programming style or a way of programming where we can break up one large program into several smaller pieces. Okay, we can develop each piece at a time, test it, make sure it works, does what we want it to, and then we can plug it into the program as we go. It's a way that we can break up a huge project into smaller, more manageable pieces. So let's go ahead and get started. Okay. We have a function definition that we have to write before we can actually use it. So I've pulled up an empty project in Visual Studio Express, and I'll just write a quick function definition and give you an example. Okay, this particular function will be a void function, and all it's going to do is print out a string hello world to the screen. Okay. Alright, so here I have my function definition, and this function definition is made up of a bunch of different pieces. Okay. This thing that I have highlighted here is called the function header. Okay, function header contains multiple pieces. It contains a return type, which I'll explain in a little bit. Here it happens to be void. It contains the name of the function. Here I've decided to call it hello, and hello is just any identifier in C++, like any other identifier. It's subject to the same rules. And the function header also has a parameter list. Okay, so in the parameter list we can define variables that a function will accept, that we can pass to this function. We can pass values to this function, and that function can utilize them. But in this case, for our hello function, there are no parameters. We don't need anything. We're not going to do anything with any values passed from main. All we're going to do is print out this string. Okay. So the last piece we have our return type, we have our function name, and we have a parameter list. In this case, it's empty. The last piece of a function that we have is we have the function body, everything between the curly braces. This is the collection of statements that make up the function. Okay, so whenever we call this function, these statements get executed. In our hello function, all we have is a single statement. See out hello world. So that's my function definition. Now that it's defined, I can actually use it inside main. Okay, so now if I want to execute the hello function, I have to make a function call. And that's what the function call looks like. Okay, it has the function name, some parentheses, and a semicolon. Forgot to return 0. So let's run this, show you a quick example. Need to pause. Okay, so I've defined my function. Now I'm going to make a function call. Okay, so we can see hello world. Okay, so the function, what happens is that as int main's executing, when it comes upon a function call, the flow of control or the flow of execution leaves main and then temporarily enters into the function itself. Okay, so as main was executing, it gets to hello. The flow of the program then leaves hello, enters the hello function, executes the cout statement, and then function finishes executing. Control is then returned to main, and main continues executing from right where it left off. Okay. So we can use, in addition to writing the definition, we can utilize these things called function prototypes. Okay. In C++, you can't use anything before you define it. It won't compile, but we can use prototypes to move this thing out of here. We can move our function definition to after int main. Okay, if we do that, then we have to have this thing called a prototype. And a prototype is basically the function header placed before int main. This allows the program to compile because now we can make this call because this function prototype tells the compiler, hey, I'm going to define my function. I just haven't done it yet. Take my word for it. Go ahead and compile, and at the end, I'll tell you what hello is. Okay, so what's the value of a function prototype? Well, what it does is it allows me to show at a glance all of the functions that I'm going to use in my program. Okay, so let's say I had another function called goodbye. Okay, and then I'm going to define it down here. Function bye, and all it's going to do is say goodbye world. Okay. So now I can just look right at these prototypes here, and I can see that this function, this program is going to have two functions defined. Okay, so now I can do hello, now I can do goodbye, and I can compile this thing in a minute. Okay, so there's the hello world. Main control of execution leaves main, goes into the hello function, prints hello world. Control returns to main. Main sees the goodbye function call, it executes it. Control now goes to the goodbye function, see how it's printed, and then execution returns to main. Okay. So prototypes at a glance, they let me see all the functions that the program has, and it allows me to define my functions after main. Okay, I can call them before I've actually defined them. Okay. So a program has to have it has to include either a prototype or a full function definition before you call them. These are function calls. Okay. These are function definitions. All right. Okay. So we can write functions that accept arguments. Okay. We have to specify a parameter list, and through parameters we can put data or values into our function. So let me write a prototype here for this function called add. Okay, when you do prototypes, if you're going to use arguments, well, these are both parameters. Okay, this is a void function named add that's going to accept two arguments. It has two parameters. Okay, so let me define it now. Void add int x, int y. Okay, so what this function is going to do is it's going to accept two values passed to it from main, and it's going to display their sum. Okay. Sum is x plus y. Okay. All right. So this is a parameter list. This is a parameter list also. This just has 0 parameters. There's no parameters in this parameter list. Okay. But this add function now has two parameters. Okay. So when we define a function, we list the parameter list, and they're basically variables that are local to the function. These are variables that will get used inside the add function. And here they are, x plus y. They're just like any other variables. They're only used within the function. Okay, so now let's go up and make a function call. Okay. So I want to add the numbers 5 and 6. Okay. So now with this function call, I'm now specifying these two arguments. In a function call, these values are arguments. In the definition, these are parameters. So now I'm using 5 and 6. I'm passing these two arguments to my add function. So 5 is then copied into this x parameter, and 6 is copied into this y parameter. Order matters, okay? So let's go ahead and run this thing. Okay, and then the sum is 11. So there it is. Okay, so now I have 3 function calls, and the third function call accepts the values 5 and 6. All right, so not only can I pass it literal values, okay, I can also use variables. Int x equals 0 and y equals 2. Okay, so now let's make our function call, add x and y. Okay, so what's going to happen is that the values that are stored in x and y are going to be copied into these parameters x and y. Okay. copies will be made, and then everything will work just as it did with the previous function call. Okay. It's okay to have these be the same names. These parameters can have the same names as these variables because they're in different scope. Okay. X and Y are in main scope, and the parameters X and Y are in add scope. Okay. Since they're in two different scopes, we can use the same name. You could have named them something different if you want to, but you don't have to. So let's compile it and see how it works. Okay. So there we go. The sum is 2. 0 plus 2 is 2. Okay. So values that are passed to a function are arguments. 5 and 6 are arguments. Okay, and the variables inside the function that hold these values that are passed as arguments are the parameters. So in this case, x and y are parameters. 5 and 6 are arguments, and this x and y are also arguments. Okay. Right. Okay, so we can have 0 or more parameters, right? It just happens to be that in this case with this add function, I just wanted to add 2 numbers. But if I wanted to add 3 numbers, I could very easily have added another parameter here. Okay. And I have to have matching number of parameters in my prototype. Okay, the prototype parameter list has to have the same number of parameters as your function definition. Okay. But see, now I have errors here because I haven't passed enough arguments. The number of arguments in your call has to match the number of parameters in your function definition. So I'll just change this. 7. And you can mix and match, right? Integer variables or integer literals, it doesn't matter. Okay. As long as they're integers, that's fine. Okay, now I have to fix this. Let's take into account my new parameter, and let's run it. Okay, so there we go. The sum is 18. 5 plus 6 plus 7 is 18, and then 0 plus 2 plus 3 is 5. So now we have an example of function prototypes, function definitions, parameters, and passing values to functions. Okay, so I mentioned earlier that when we provide arguments or pass arguments to a function, copies are made, right? So when I'm doing this, when I pass x and y here, the actual x and y variable values aren't given to the add function, okay? A copy of 0 is made, and that copy is what's given to the function. A copy of y is made, right? So a copy of 2 is made, and that 2 is what's given to the function. Right, so what does that mean? This is what's called passed by value, also known as passed by copy. And I'll give you an example right here. We'll write a void function called change me. Okay, and all it's going to do is going to accept a single argument. It's going to have one parameter, and it's going to attempt to change a variable. Okay, so we'll have it num. And all it's going to do is try to change num somehow. Okay, so num equals 0. Okay. So I'll pass it y. Okay, change me y, and then I will print y before. And I'll print y after. And you'll see that y is going to be the exact same. Okay. Even though I tried to change it in the function, nothing's going to be different. Okay, y is still 2. That's because I passed change me a copy, not the original. The original is still safe inside the y variable. It's the copy that gets changed. Okay, so that copy value 2 is what's changed to 0. Once this function finishes executing, that copy is thrown away. Whatever it's been changed to is thrown away. It goes away. The original is still safe. Okay. Oops. Okay. So there is a way that you can make that change permanent, and that's called pass by reference. Okay, and when we pass by reference, what we're doing is we are giving it the original value. Okay, so let me write another function. Type. Okay, and to designate that a value that you are, or a variable that you're passing to a function should be passed by reference, we add this little ampersand. That ampersand is the address operator. Okay. So let me now define it. Okay. The address operator has to go between the data type and the parameter name. So now if I do num equals 0, this will actually change y permanently. Okay. Oops. Alright, so now let's run this thing. We're now going to pass y, the exact same y, except this time we're going to pass the original value, and any changes we make to that original value are going to be permanent because we are passing it by reference. Notice the function call is the exact same. It's only the parameter list that changes. Let's run it. Oops, go there. That's my error. Oh, I forgot an E. Sorry. Alright, typo. Alright, let's do this again. Run it. We're going to see this time it has changed, right? Because the first example was a pass by copy. We made a copy of the value we gave to the function, and that was the copy that was changed, not the original. In pass by reference, we handed the original, and so the changes are made to the original, and so they are permanent. So that is pass by reference. Make some notes here. So this is pass by copy and pass by reference. Okay, so we can also, in addition to everything we've talked about so far, we can also return a value from a function. So far, all the functions we've written have been void functions. They don't return anything. Okay, so when a void function is finished executing, once it reaches this second brace, it finishes executing, it dies, it goes away. Right? It doesn't give anything back to the function that called it. Well, we can write a function that will actually return a value. So let's say that I wanted to subtract two integers. Okay, I can specify a return type of int. Okay, and I can write my function prototype. I'm going to subtract two integers. Okay, so now we can go on this thing, int sub int x int y. Okay, so I'm going to accept two arguments that will be copied into my parameters x and y, and I'm going to use this return keyword, okay, to return the difference. Okay, so what's going to happen is that when I call this, let's make the function call sub x and y. I'm going to pass it. I'm going to copy 0 and 2 into the sub function, and then sub is going to subtract y from x and return that value. Okay. Okay, and when it returns that value, it's going to return that difference. Effectively, what happens is that this sub call gets replaced whatever that value was. Okay, so I can then turn around and assign that value to a variable. Okay, so we'll store the difference of x and 2 inside x. Okay, and then I will print out x. Okay. So let's run that, see what happens. So in this case, 0 minus 0 is going to be 0 because we made that change permanent in the change me2. Alright, but what if I wanted to see something a little interesting? Not only can I store whatever the function returns inside a variable, I can just send it straight to cout. So let's say I want to know what 3 minus 10 is. Okay. I can just put this right into a cout statement. Okay, and let's run that. There we go, 3 minus 10 equals negative 7. Okay, so now every time I want to run this or subtract a number or add a number, I just make these function calls. And I can make them over and over and over and over and over again without having to rewrite everything that was inside them. Okay, that's one of the beautiful things about functions. Now let's say that I was working on a team or this was a big project and I knew that I wanted these 3 functions, right, but I couldn't write them all at the same time. Or maybe I wanted one team to work on hello, maybe I want another team to work on goodbye, somebody else on add, etc. I can give everyone this job, you develop hello, you develop goodbye, you develop add, they write the thing, and then we can plug it in as we go. Okay. Alright, so I think I'm getting a little tired, so I think we'll go ahead and stop there right now. We've covered a lot of stuff. We've talked about prototypes, we've talked about returning values from a function, we've talked about pass by copy, we've talked about pass by reference, and we have talked about function definitions, the parts, we have a return type, and this can be any data type. Okay, we've talked about the name of a function. Okay, this can be any valid identifier name, the parameter list, and the body. We can have as many statements in here as we want inside a function. It's totally fine, and we can return any value. It's important that you keep in mind that you need your return value and your return type should match. And if you try to return a float from sub, for example, we're going to lose those decimal places, just like if we had assigned it to an integer. Okay, if we were to pass doubles into sub the way this is written right now, we'd lose those decimal places because it accepts integer arguments, right, not doubles. They'll be downgraded to integers, and the decimal places will get truncated. Okay, so next time when we start talking about functions again, we'll talk about local and global variables. We'll talk about functions and menuing systems. We can write programs that use menus and implement them using functions. It's a really great way to write programs. We can talk about initializing variables. We'll talk about initializing the parameters, and we'll talk about static variables and a few other things too. Okay, so that'll be it for this part. This will be part 1, and I'll do another part soon. Okay, thanks for watching, and have a good night.